In this video, we'll go over the last topic of the transformations unit, which is inverse of a function. So the very first question we should ask ourselves is, what is the inverse of a function? How do you find the inverse function? Well, the inverse function, quite simply put, it undoes everything that the original function does. Okay? And I've used the word inverse quite often when I taught grade 9. I would repetitively say you perform, when you're trying to solve a linear equation, for example, I would repetitively say perform inverse operations. Okay, and that makes sense because you want to undo the effects of, I don't know, like add 4, so you subtract by 4 to both sides. So it's exact same logic. So if you have an original function that does something, the inverse will undo it and bring you back to the beginning. So if you're trying to find the inverse function, there are 4 simple steps you follow. So if it's not already in function notation, if it's not already in y equals form, then you should change it to y equals instead of f of x. And then interchange x and y, and then solve the new equation for y, and replace y with inverse f of x. Okay, so let's try those 4 steps and find the inverse. So replace f of x with y, interchange x and y, and then solve for y. And lastly, replace y with inverse f of x. So now that I'm looking at the answer, okay, I'm thinking about it. I was like, wait a minute, I did not need to do all this work. Okay, take a look at the original function. What are you doing to the input? You're multiplying by 2 and then you're subtracting by 3. You multiply by 2 and then you subtract by 3. So if that's what this machine is doing, you're taking input values, multiplying by 2 and subtracting by 3. How do you undo the effects of this machine, this function machine, to get back to the original input value? Okay, one more time. Multiply by 2, subtract by 3. So to undo it, you would add by 3 and then divide by 2, right? And that will get you back to the original input value. So the inverse undoes everything that the original function does. Now this one's a little more complicated, so it's a little harder to determine the inverse just by staring at it, but certainly for 1a, I could have done that. I could have wrote the inverse right off the bat. Alright, so change it to y equals, interchange x and y, and now I'm going to try to solve for y here. Now this one's a little bit more work. So multiply both sides by y plus 2. And then distribute here. And then I'm going to bring the terms with y to the left side here. And I'm going to factor y because I want to isolate it. Alright, so there's my inverse. That's the inverse of f of x. Alright, let's try this word problem down. For example 2, a water tank already contains 55 liters of water when Haley begins to fill it. Water flows into the tank at a rate of 8 liters per minute. The volume V in liters of the tank after t minutes is given by the function v of t equals at plus 55. Determine the inverse and its meaning. So the good news is that this function is as straightforward as it gets. It's a linear function. You can find the inverse very quickly. So I'm gonna find the inverse very quickly, but don't copy this part down because I'm going to show you something wrong with it. Well, nothing drastic, but there is a problem. So 8t plus 55. So how do I undo that? You subtract by 55 and you divide it by 8. So I can find the inverse very, very quickly here. But wait a minute. This is a little confusing, okay? Because right now, when you find the inverse, t does not represent time anymore. When you're working with the inverse, t represents the volume, which is very, very confusing. So when you're working with word problems, we're going to change up the notation, okay? If you're simply working with x and y, like what you did before, go ahead. This is beautiful. But with word problems, because there's meaning to the variables, it gets a little confusing with that notation. So I'm going to cross it out just so you don't write it down. So what you do, we're going to change v of t to v. And we're going to, instead of interchanging the variables, we're just going to isolate for the independent variable here. So v minus 55 equals 8t, and divide both sides by 8. And now we're going to express it as a function. So t as a function of v, which is the inverse of v as a function of t, right? So what is the meaning? Okay, let's write the meaning. The inverse represents a function that gives the time, gives the time in minutes as a function of volume in liters. Okay, so the inverse is perfect if I'm trying to find the time that is needed to fill the water tank to a specified volume. Okay, so if you say I have a volume of I don't know, 100 liters, then I can solve for the time very easily. Okay, you want a volume of 100 liters? No problem. The inverse will be very will be perfect to solve for the time needed to fill it to 100 liters. Whereas the original function is great if I'm trying to determine the volume after a specified amount of time. So both are useful. Okay, so don't neglect the inverse. But I wanted to bring up this question because in the homework you'll have some word problems, and I don't want you to be alarmed when I change the notation. Okay? All right. Okay, so the inverse is really, really nice, and there are a lot of things I can say about it, and I try to keep it to a minimum, but there are still quite a few things I wanted to say. So the first thing I want to say is that when you're working with the inverse, the x and y values are interchanged between the function and its inverse. Okay, in fact, that's what we did in example 1, right? The independent variable becomes a dependent variable, and the dependent variable becomes an independent variable. So quite simply said, you've switched x and y. Okay, so if you've switched x and y, that means the domain of the function becomes the range of the inverse. And the range of the function becomes a domain of the inverse. And you have to be very careful, because sometimes when you take the inverse of a function, the inverse is not a function. Okay? Sometimes when you take the inverse or find the inverse of a function, the inverse may not be a function. And sometimes the inverse is a function. So if the inverse is a function, then we say that the function is invertible. If the inverse is not a function, we say that it is not invertible. Now, I will say that we really prefer that the inverse of a function be a function. We really like it to be invertible. In fact, when it is not invertible, we restrict the domain such that it will be invertible. Our functions are invertible if it is a one-to-one function. Quite simply said, a function that passes the horizontal line test. So we already talked about the vertical line test, but now we're bringing up the horizontal line test. The horizontal line test. Okay? So if you pass the horizontal line test, that means your function is invertible, which means your inverse is a function. Graphically, the function and its inverse are symmetrical about the y equals x line. So that's the reason why we put this lesson in this unit, because they are related in terms of a reflection across the y equals x line. When we graph it, you'll see it's beautiful. Okay, so let's put all that together. Okay, so looking at the graph of each function, determine whether the function is invertible. So we said that, let's check if it's passing the horizontal line test. Yes. So this function is clearly passing the horizontal line test. So is the function invertible? Yes. How about this guy? This quadratic function, is this invertible? Well, clearly it's failing the horizontal line test. Okay, so I'm going to approximate it. This is probably not true. I'm just going to make this up. So you have negative 6.55, and we have, let's say, half 5. Okay, so when you switch the x and y values, right? That's how you find the inverse. X becomes y and y becomes x. So what you're going to get is half 5. So it'll be 5. Oh, it's just off the grid. Anyways, you'll get half. So 5 half. And 5 negative 6.5. And that's why we want it to pass the horizontal line test. Because if you fail the horizontal line test, it's clear that I've shown you that you're going to fail the vertical line test. Well, the inverse will fail the vertical line test, right? Because they have the same y values here, right? If they lie on the same horizontal line, they have the same y values, which means the inverse, the 2 points will have the same x values. And if they have the same x values, they fail the vertical line test, right? So that's how the horizontal line test works. Okay, so no. Okay, this function is not invertible. So as I was saying before, this is a little complicated and you don't really do this very often, but we really prefer the inverse to be a function. So what we do is we restrict the domain of the quadratic function. So we hide half the parabola. So if you hide half the parabola, hey, now it passes the horizontal line test. So we want to restrict the domain such that it will pass the horizontal line test because we really prefer that the inverse be a function. Okay? All right, so let's take a look at this question here. Determine the inverse. We have f of x equals x plus 3 all squared minus 4. Ooh, you see, that's a quadratic function. Without this restriction on the domain, it's not invertible. So what they did is they stated a restriction. So x now must be greater than or equal to negative 3. So now I'm looking at the right half of the parabola. So it is invertible. So let's find the inverse. So it's not a word problem, so we can go with our simple steps. Okay, y equals x plus 3 all squared minus 4. Interchange x and y. And now let's solve for y here. Oops. Ooh. X. and square root both sides. Okay, hold on a minute. So we have to reject something here. Okay, so should we reject the plus or the minus? How can I know what is the restriction on x here? Well, I'll give you a hint. Domain of the original function becomes the range of the inverse. Domain of the original function becomes the range of the inverse. So we want the output, the range has to be greater than or equal to -3, right? Domain of the original function is the range of the inverse. So that means that the output values have to be greater than or equal to -3, which means I have to reject this one, the minus. Oops. I reject because y is greater than or equal to -3. That's the range. There we go. And that's the inverse. So I gave you a beautiful grid here just so I can graph the half parabola and its inverse, because I want to show you it's symmetrical about the y equals x line. So I'm going to plot it first, -3, -4, -3, -4, -3, -4, 1, 2, 3, 4. Okay, I'm looking at the right half of the parabola. I use my step pattern, which is 1, 3, 5. Perfect. Okay, and when it comes to graphing the inverse, you don't have to do much work. Look, if this point is -3, -4, just swap it around. It'll be -4, -3, -4, -3. If this point here is -2, -3, it'll be now -3, -2. Remember, x becomes y, y becomes x. This is -1, 0, so it'll be now 0, -1. And lastly, 0, 5, 5, 0. Oh, this one's not that easy to graph. Okay, and let's sketch it in. Let's sketch it in to really emphasize that is why we put this lesson in the transformations unit, because the original function and its inverse, if you graph them both, they're symmetrical about the y equals x line. Beautiful. Well, I could have done a better job with my inverse, but we'll live with that. We'll live with that. Okay, so after I graph the inverse by interchanging x and y, I'm feeling even more confident about what I've written here, rejecting that negative root. Because this is supposed to be, it's supposed to be, if you think about transformations, this is the square root function shifted 4 units to the left and 3 units down. Yep, and that's it, no reflection. Okay, so that's the last lesson of the transformations unit. Hopefully you have a pretty good idea of inverses.